Hi everyone, Mr. Rubin here. Okay, so today our aim of today's lesson is multiplying and dividing algebraic fractions with a reasonable amount of confidence, and we're aiming to also apply our prior knowledge of multiplying and dividing fractions. Okay, so essentially we're applying that prior knowledge of how to times and divide fractions, and we're applying that into an algebraic context. So let's first of all look at what we know previously about multiplying and dividing algebraic fractions. Now, adding and subtracting fractions tends to be a bit more trickier than multiplying and dividing. As with multiplying, we can see with this one here, we've got 3 over 5 times 2 over 7. Now, with multiplying fractions, we don't need the denominators, so the numbers down the bottom, the denominators don't need to be the same for us to work this out. Whereas with addition and subtraction, the first step we'd want to do is to make these two the same. However, in this case with multiplication, it doesn't matter. So that's a step that we get to miss. So let's look at timesing 5. So the denominator and the denominator times together, and the numerator times together. Okay, simple as that. So let's look at the first one. What's 3 times 2? You've got it, that's 6 over. What is 5 times 7? 35. And there you have it. So can that simplify even further? At this stage, I don't think so. Okay, let's look at the bottom one. Now, there is an extra step with this one down here, okay? So we've got 3 over 5 divided by 1/3. Okay, sorry, that's 4 over 5 divided by 1/3 equals, well, who remembers what the reciprocal is? Now I'll spell that. Reciprocal. So basically, the reciprocal is the fraction on the right, okay? It's always the one on the right. We flip it, okay? We flip it and times it. That's what we need to remember with dividing fractions. We flip it and times it. Maybe you can come up with some sort of a song or way of remembering that, okay? So the fraction on the right, we flip it and times it. So if we were to rewrite this, so the 4 over 5 stays the same. However, when we flip 1/3, we get 3 over 1, don't we? However, we don't divide, okay? We multiply now, okay? So it then becomes 4 times 3 and 5 times 1. Remember the numerator by the numerator and the denominator by the denominator. So if we start with the numerators, 4 times 3 is 4, 8, 12. Over. What's 5 times 1? 5. Can that simplify any further? No, but we can write that as a mixed number. So how many 5s go into 12? 5, 10. That would leave us with 2 5s go into 12. What's our remainder? 2. And our remainder sits on top of the denominator there. So we're left with 2 and 2 over 5. Okay? So let's look at some examples with algebra now. So first of all, we multiply the numerator and denominator separately, okay? Just like we did with the fractions before. So let's go. The top 4x times multiplies by the 2y, and the 7 is multiplied by 11, okay? So this will give us 8xy, because 2 times 4 is 8, and the x and the y are still, we haven't solved anything there, okay? That still means x times y, okay? So the only thing that we've solved there is the 8 times x times y, okay? Now let's do the bottom one. What's 7 times 11? You've got it, 77. So our answer there is 8xy over 77. There you go. Let's look at the bottom one now. So we've got 2x times 10y, and 5 times 3. So 2 times 10 is, you got it, 20. What's x times y? Well, there you go, x times y, we've got it. Now, 5 times 3 is 15, okay? Now, if you didn't quite get that, we times the numerator by the numerator, starting with the numbers. So we went 2 times 10, that's 20. Then we went x times y. Now that simply is written as x times y, okay, or x and y next to each other. Reminding ourselves that that just means that they're timesing each other, okay, or multiplying by each other. Now at the bottom, the denominators, we've got 5 times 3 giving us 15. Now, can this be simplified? That is the question. Yes, it can. So we need to find a common factor between 20 and 15. Okay? Common factor would be 5. So how many 5s? How many 5s go into 20? You've got it, 4. How many 5s go into 15? Down here. That would be 3. And so our final answer there is 4xy over 3. Okay, now if you were to write this neatly, the 3 would be in the middle there. Okay, of course you'll all write better than, a lot neater than what I will, for sure. Alright, we're doing well so far, guys. So we've looked at multiplication and division of fractions. Now we've just looked at multiplication of fractions with algebraic terms in them. Now we are up to dividing fractions with algebraic terms in them. Okay, now some reminders up here. Division, first flip and times, then same as the last example. So what that means is, as we saw before, we need to find the reciprocal of the fraction on the right. So what is the reciprocal again? Reciprocal means to flip it. So remember, flip and times this one. So if we rewrite it underneath, I would use a different colour. We're left with 2a over 5. That stays the same. Now, is it divide or times? Times. Now we flip 3b over 4, and that then becomes 4 over 3b. Equals, now, top times by the top, bottom by the bottom, numerator by the numerator, so that would mean what is 2a times 4, that would give us 8a, wouldn't it? Excuse my dodgy a. Now, for the denominators, what's 5 times 3b? That would give us 15b. And there you go. Alright, well done guys so far, we're doing well. Here's our last couple of examples. I thought I'd go over these two because, well, there's one extra step involved in these, that's very important. Now, same as before, we multiply the numerators by numerators, denominators by denominators. However, this one here is a little different because we've got 3a times 7a. Now, the thing I want to point out here is that when we do the same with the numbers as we always has, which is 3 times 7, that would give us 7, 14, 21. Now, what happens with the a's, however, here? So we've got a times a. Now, if we remember back to working with, or multiplying like terms, that this a then becomes squared because there's two of them. Now, you could just write 21 times a, which would mean the same thing. However, we can write it in shorthand by writing 21a squared, okay? Over, and then we solve 2 times 5, meaning 10. And that can't be simplified any further, so there we have our final answer. Okay, I'll show you another example on the bottom, which I've forgotten to put in a y, so I'll just add that in. There you go. So, we've got 2y divided by 3. Hang on. 2y divided by 3 and x divided by 3y. What happens? We need to find the reciprocal of the fraction the algebraic fraction on the right, so that's that one, and we'll rewrite this, okay, finding that reciprocal, so 2y over x times 3y over 3. Remember, we flip it and times it. So let's times these two together. Hopefully we can have enough room here. 2y times 3y. That would then give us 6y squared. Got it. You knew what was going to happen, didn't you? Now, on the bottom, x times 3. Well, we will just write that as 3x. You could write that as x3, but that would be incorrect. It's the incorrect way of representing it. So we'd always write that as 3x with the number in front, okay? And there you go. So hopefully after watching this video, you will, with confidence, be able to multiply and divide algebraic fractions, okay? And hopefully our prior knowledge of multiplying and dividing fractions will help us to do that, okay? Now, just one last reminder or reflection, I'd say, about when we're multiplying like terms. So A and A, when multiplying like terms, they then become either squared or cubed. So for example, if we had A times A times A, because there's 3 of them, that would equal, sorry, I'll just rub that out, because there's 3 of them, that would equal, what do you reckon, A cubed, depending on how many they are, 1, 2, 3, or 4 or 5 or 6 or 7, that number of letters would then become to the power of, okay? Alright. Well, hope you enjoyed that one. Thanks, guys.